All right, let's talk a little bit about lesson 87 in Saxon Math 54. And as we do, we're going to continue to talk a little bit about multiplying, and we're looking at two-digit numbers. Looks like this is part one in a series. So, if you haven't already, go ahead and do some of the warm-up problems here, and come back and we'll talk about them and give you just a little hint here and there. Don't negate your multiplication facts, so you might want to look back at test G and just look back at all of those multiplication procedures. Mental math, take your time doing those. You definitely want to be able to master the skills of these operations: subtraction, multiplication, division, and addition. And so the easier, math would be so much easier if you can master those, master estimating, master the simple operations, because you will use them through all the rest of the levels of math as you move forward. Let's look at this problem-solving problem here. It says Sandra bought a CD priced at $12.95. Sales tax was $1.10. She paid for her purchase, with a $10 bill and a $5 bill. So Sandra got back 5 coins, not including a $half. What were the coins? Now, and Sandra should have received, what are the coins that she should have received in change is what they're asking. Now that's a lot of information in one problem, but you have to take it bit by bit, break it apart, and just deal with little chunks of the information. Also, you want to realize, look at the question here at the end and kind of realize where you're going, what direction are you heading. You're trying to look at change, the change that she received. So you want the difference between what she owed and what she gave, how much money she gave the cashier. That difference between those two is going to be basically the change that she receives back. Okay? So let's figure out the total amount that she owed the cashier. The price is $12.95 for the CD, and the sales tax is $1.10 total. It looks like $1.10 total. Okay, so the total price that she owes is going to be the sum of those two. Let's add these together. She owes $14.05. She gave a $10 bill and a $5 bill. So she paid a total of $15. Those two together, 10 plus 5. And the difference between those is going to be what she gets back in change. So you have to take 15 minus 405. When you do that, you're going to get 95 cents. It says here she got 5 coins. She got back 5 coins. So we need to figure out what are the 5 coins that she received that would add up to the 95 cents that she got back in change. Okay? So obviously the coins that, the coins that we use in the United States, you've got a quarter, which is 25 cents. You've got a dime, and you've got your nickel. So quarter is 25, dime is 10 cents, nickel is 5 cents. It says you're not counting a $half, so you're not using the 50-cent piece. Oh, and we have the penny, of course. I don't think that's going to be needed because you'll notice it's 95 cents, ends in a 5. Okay? So we need 5 coins that are going to add up to 95 cents. So let's take quarters. 2 quarters would give us 50 cents. 3 quarters would give us 75. So right now with 3 quarters we got 75 cents. We need to get another 20 cents to get to 95. So another 20 cents, you're just going to need another, not another, but you're going to need 2 dimes. 10 and another 10, add it on to 75, would get you to 95. Okay? That's 5 coins. You're set. You're done. Alright, our new concept today, as mentioned, we're going to be looking at multiplying two-digit numbers. And it says here, first we multiply by the ones digit, and next we're going to multiply by the tens, and then we add the products in order to get the final answer. So, for example, to multiply 34 by 12, you're going to take 34 by the 2, which is in the units place, and then multiply 34 by 10, and then add those two together. We'll look at some other ways to approach this as well, but we'll start with this. So 34 times 12. So we're going to take 34 times 2. So 34 times 2 is 68. And then we're going to take 10, because really that 1 right there is not just representing 1, it's in the tens place, so 110 is what that's talking about. That 1 is representing 10. So we know that when you multiply by 10, you're going to have a 0 at the end. That was from a previous lesson, remember? So then if you just take 1 times 34, that's 34, but 10 times 34 is 340. And then you just add these two numbers together. So 8 and 0 is 8, 6 and 4 is 10, carry the 1, 3 and 1 is 4, 408. Okay? You can do this also by multiplying the tens first. Sometimes I find that easier. So if I take 10 times 34, 10 times 34 I know is 340, and then 2 times 34 is 68. You add those together, you're still going to get 408. Sometimes for some reason I find that is maybe easier in some cases. Okay? But either way, you take the two numbers, multiply them by the other number, and then add those two results together. Okay? And that's what all this is saying here. They're just writing out exactly what we just talked about. Notice that this 0 is a result of knowing that that 1 is in the tens place. Notice there's a blank right here, right now. Alright, but you put a 0 there because you really know that 1 is not just 1, it's 10. Okay? Here's another one. 31 times 23. So if you take 3 times 31, 3 times 1 is 3, 3 times 3 is 9. And remember, this is 20, so we're going to put a 0 there. And then 2 times 1 is 2, 2 times 3 is 6. Add those together. Just add straight down. Make sure you keep everything lined up. That's the other reason we put a 0 here, is because we have to line up everything so that they're in the right place value when we combine these two products. 9, 11, 9, 10, 11, carry the 1, that's 7, 13 is your final answer there. Okay? So you need to practice these now. You need to take and practice this set right here, multiplying two-digit numbers. Take your time, be methodical, don't need to rush through this. Practice, practice, practice. The more you do it, the easier it gets, the better you'll be able to master this skill. It is a skill. It's a skill that you have to be able to do. And as you're doing this, you also might want to practice doing some of it in your head. Not that you want to rely on that, but just try doing a few things in your head and confirm it by writing it out and doing the steps on paper. Okay? Okay, you can pause here after you've done everything and make sure you then work through the mixed practice and then come back and we'll talk about some of these problems. Our problem set, as we walk through these, you'll notice that here, this information that's given is for problems 1 through 3. So Freeman rode his bike 2 miles from his house to Dee Dee's house. Together they rode 5 miles to the lake. Dee Dee caught 8 fish. At 3:30 p.m. they rode back to Dee Dee's house. Then Freeman rode home. Again, lots of information, lots of numbers. So you have to be really analytical and careful and concentrate so that you know exactly what of that information you really need in order to answer whatever questions they're asking. So you'll notice here it talks about distance, it talks about number of fish, it talks about time. So make sure that you are zeroing in on the information that you need. Question number 1, referring back to this information. Altogether, how far did Freeman ride his bike? So altogether, well, let's add up all the separate distances, the separate parts of his travel. Freeman rode his bike 2 miles. So I'm going to write that down. 2 miles. Don't try to do it all in your head. Jot it down so you don't make mistakes. 2 miles from his house to Dee Dee's house. Together, now Freeman's still riding, so together they rode another 4 miles. So let's add 4 miles onto that, to the lake. And then it doesn't give you numbers, but it does say they rode back to Dee Dee's house. And then Freeman rode home. So he's going to ride back the 4 miles and back home the 2 miles. So you're going to add all these up. 2 plus 4 plus 4 plus 2 is going to be 12 total miles is what he rode. It took Freeman an hour and a half to get home from the lake. At what time did he get home? Because it says here at 3:30 p.m. they rode back to Dee Dee's house and then Freeman rode home. So we're starting at 3:30 at the lake, and then it takes him an hour and a half. So you want to go 3:30 p.m. and then he's going to travel for 1.5 hours, which is 1 hour and 30 minutes. Hour 30. So you're going to take the 3:30 p.m. and you're going to add 30 minutes. That puts you at 4. And then another hour is going to put you at 5 p.m. Okay? Dee Dee caught twice as many fish as Freeman. How many fish did Freeman catch? So twice as many. That means the number that Dee Dee caught, I'll put a D there for the fish that Dee Dee caught, is equals, is means equals in math, twice the number as Freeman. And I'm going to put 2 times F, for the F is the number of fish that Freeman caught. So the number that Dee Dee caught, D, is 2 times the number that Freeman caught. Okay? You don't need the multiplication symbol when you've got letters. You can just write a number and a letter right next to each other, and it means multiplication. Okay? So, it says up here, Dee Dee caught 8 fish. So if this D right here, they tell us is 8, well that, if you take 2 times some number, you will get 8. So Freeman must have only caught 4, because 2 times 4 is the 8. Okay? Or 2 times something is what they're asking. 2 times something is 8. So that number is 4. Okay? Let's move on here. Number 4, Shep bought, now we're off of the information up there above, where this is a separate problem now. Shep bought some feed priced at $12.95. Tax was 91 cents. He paid with a $20 bill. How much money should he get back? So first, find out how much he owes. Add that up, find that number, and then take your $20 and subtract whatever number this is here. Okay? And you'll find out the change that he is due. Number 5, estimate the sum of those two by rounding each number to the nearest thousand. Thousand would be the 4 is in the thousands place, the 3 is in the thousands place. 4,876, you're going to round that up to 5,000. And the 3,149, round that down to 3,000. If you subtract those, you get 2,000. So approximately, the difference of those two is approximately 2,000. Number 6, what is the tally for? What is the tally for what number? Or this is the tally for what number? Excuse me. So there's a 5, there's a 5, and 4 more. So 5 plus 5 plus 4 is going to give you 14. What is the perimeter of a pentagon that has 5 sides if each side is 20 centimeters? So 1, 2, 3, 4, 5. Each is 20, 20, 20, 20. All of them are 20. And you're going to add those all up, or just take 5 times 20. Okay? Number 8. Find the length of this segment to the nearest quarter inch. So you'll notice that this is measuring by inches, and every mark there is a quarter of an inch. So we're going to measure the length of this segment out to here, and that is the closest segment right there, it looks like, and that is 3, and then 2 quarters. So this is a quarter, and another quarter is a half. So that's 3.5 1.5 inches. 1/2 of the 18 players were on the field. A half of 18. See this of word right there? That of means multiplication. So half of times 18. That's what that means. How many players were on the field? Draw a picture to illustrate. So you could say also this box here represents all the players, and you're going to take half. So divide it right in half there. Those 18 are going to be divided into 2 equal halves. So that means 9 are on the field, 9 must be off the field. It's asking how many are on the field, and that would be your 9. Number 10, a dime is 1/10 of a dollar. What fraction of a dollar is a penny? So a dime is 10 cents, a tenth. A penny is 0.01. That is 1/100th of a dollar. A dime is 1/10. It takes 10 dimes to equal a dollar. It takes 100 pennies to equal a dollar. And the percent, that percent is 1/100, 1%. A dime would be 10% of a dollar, the value of it. 283 miles of a 1,000-mile trip were through the desert. What fraction of the trip was through the desert? So 283 of a 1,000-mile trip. Okay? What fraction of the trip was through the desert? So right there, you've got it written out for you. 283 out of 1,000. 283 out of 1,000 of the miles. Number 12, we're going to write it as a decimal. So this here, 1,000, you remember, is the third decimal place after to the right of the decimal point. So when you divide by 1,000, you take your number and you move the decimal point 3 places. So 283 thousandths is the same thing as 0.283. Okay, I'm going to let you do all of these. So you do all of these 14 through 25, and let's jump down to 26 and talk about the perimeter and area. Perimeter, remember with a rectangle, opposite sides are going to be equal in length, so that's 20. That one's 10. Add up all 4 of those sides to get your perimeter. Area is how many squares fit into that space, into that shape. Well, you've got 20 squares that can fit the length, and you've got 10 that can fit down, so you're going to have a total of 20 times 10 squares. 20 times 10. Length times width is going to give you the area of a rectangle. Take 20 times 10, and remember that is going to be in square units. Inches squared. How many squares are going to fit? Draw an equilateral triangle. Equilateral means all the sides are equal in length, with sides 2 centimeters long. So this is 2 centimeters, this is 2 centimeters, this is 2 centimeters, all of them are 2 centimeters. That's your equilateral triangle. Okay? Equal sides. That's what that means. What is the perimeter in millimeters of the triangle you drew? So the perimeter is the distance around. 2, 4, 6. It's a total of 6 centimeters, and we're going to change that to millimeters. Well, there are 10 millimeters in every centimeter. I'm using a unit multiplier. So centimeters cancel. This tells me I'm going to take 6 times 10, or 60 millimeters is the same as 6 centimeters. In this polygon, which side appears to be parallel to side AB? Here's AB. Parallel would be CD. Parallel lines never cross. So if you were to even extend these, continue these out further, they're never going to intersect. Which angle in the quadrilateral in problem 29 looks as if it might be 110? Okay, remember 90 degrees is when you have perpendicular lines. So 110 is going to be a little bit more than that. If this is 90 degrees, 110 is going to be a little bit bigger than that. 110, something like that, measured from this side over here. You could also measure from the other side, doesn't matter. Okay? That could be about 110 if this is 90. So we're looking for one that goes a little bit past 90 degrees. And that probably is going to be this one right here. Okay? All right. I hope that helps. Let me know if you have any questions, and keep up the good work.